Good morning. Today we're going to talk about section 1.5, but a reminder that your deadlines tonight for Wednesday night are that introduction discussion that's on Blackboard. And then you also need to complete section 1.4 and day one and day two. Most of you have already done that, but just in case, that deadline is 11:59. Your next deadline is Saturday night. That's for sections 1.5 and 1.6. So today we'll lecture on section 1.5. It's one of our easier sections. I don't think there's anything new that's going to surprise anybody in the section. Section 1.5 is all about solving linear inequalities. Okay, but before we do that, I want to make sure everybody is comfortable with interval notation. So it's the most concise way. You'll use it in your classes moving forward from here. So let's take a brief moment and talk about interval notation. So using interval notation. I'm going to start off with notation with some guidelines. So just some general guidelines to remember. First thing is they're always in numerical order from left to right. So we always write our intervals in numerical order. That means smaller number on the left, larger number on the right. And I know that seems like a really strange comment to make, but I see a lot of people who write things out of order. So don't do that. You always want to make sure that you use a parenthesis or a less than or greater than symbol. You're going to use a square bracket for the less than or equal to, or a greater than or equal to symbol. You always use a parenthesis next to the infinity symbol. Okay, so let's make sure that the parenthesis and the square bracket makes sense to you. So in terms of parenthesis, we consider that to be exclusive, meaning it excludes the endpoint. We consider the square bracket to be inclusive, meaning it includes the endpoint. Inclusive. So the reason you always use a parenthesis next to the infinity symbol is because you don't know what number is out there, so you cannot bracket it in because it's not a specific endpoint. So those are just, again, general guidelines. Again, always write them in numerical order from left to right. Make sure you use a parenthesis when you have a less than or a greater than. Those are exclusive, meaning you do not want to include the endpoints. You want to exclude those endpoints. You want to use a square bracket for anything that's a less than or equal to or a greater than or equal to. Those square brackets include those endpoints, meaning that they are part of the picture or the answer or the solution. And anytime you have an infinity symbol, always put a parenthesis next to it. So as a point of fact, parenthesis is a plural form. Parent is just a single form of that. So that's much more awkward for us to say. Let's go ahead and start solving them. Actually, before we start solving them, let's go ahead and just translate a couple of things. So what we're going to do is make a table. So the first one, the first column is going to be the inequality. This is what you would get when you were finished solving. The next one's going to be the graph. It's a number line graph. And the last one's going to be the interval notation that accompanies that number line graph. And again, this is just background to make sure everybody's in the same spot. So let's say you're solving a linear inequality, and all of a sudden you end up with an answer something like x is greater than 5. So what the book is going to have you do is graph that on a number line. So all we need is the number 5. We don't really care where any other number is. I don't need to mark 0. All I need is that number. Because it's a greater than without any equal to it, we know that we can use an open circle to start at the 5. And then the inequality points to the right, or we need all numbers that are bigger than 5. Numbers that are bigger than 5 are to the right. So there's the graph that accompanies that. And from this picture, we're now going to write the interval notation. So we'll notice that from left to right, the first thing we see on our graph is the number 5. Because we put an open circle there, we're going to put a parenthesis next to the 5. That backs up the fact that that parenthesis matches up with that greater than symbol. And then we're going off to the right. Well, off to the right, the numbers that are on to the right are heading towards positive infinity, and we always put a parenthesis by that. So here's the inequality statement. Here's the graph that matches that, and then here's the actual interval notation. Sometimes you'll see, or you will come from places where instead of using an open circle, they'll actually use a parenthesis. So an alternative form of this picture that means the same thing is to use the parenthesis there, going off to the right. Either one's acceptable. We tend to use the open circle and closed circle in our class. So let's do another one just to make sure you're comfortable with it. So another line in our little table. Let's do x is less than or equal to -4. Now the sign of the number is just something I'm making up as I'm doing this. So we'll put a number line and put our -4 on it. This time the inequality includes an equal sign on, so that means we're going to use a closed circle, which means to include that number as part of the solution or the answer. But in this case, we need all numbers that are smaller than that. So numbers that are smaller than -4 are to the left. So the graph looks like that. Now we'll go write the interval notation that accompanies that. So this time again, moving from left to right, the left side of this graph is actually out there at -infinity. We'll put a parenthesis by the infinity symbol. This time the graph is stopping at -4, and because it's a closed circle or because of the equal to clear back over here, we know we're going to use the square bracket. So all 3 of these pieces of information tell us the exact same pieces of information. This is telling me to use all the numbers that are less than -4. This is telling me to use all the numbers that are less than -4, and so is this. So we'll use numbers that are less to and including that -4. Now, sometimes you'll have compound inequalities. A compound inequality simply means it has more than one inequality symbol in it. So you might see something like -1 is less than x is less than or equal to. Let's put a fraction in there just so you're not afraid of those fractions. This time on our number line, we actually need the 2 numbers. So we'll mark the -1. We'll mark the 1/2. Again, make sure they're in numerical order. It's a number line. The -1 goes on the left, the 1/2 goes on the right. Back with our inequality symbol, next to the -1 is a less than, not an equal to, just a pure less than, so we'll use an open circle there. In terms of the 1/2, it's got a less than or equal to, so that equal to is telling me to close that circle in. We'll notice that x is trapped between the -1 and the 1/2, so our graph is trapped between the -1 and the 1/2. So again, here's the inequality statement, here's the graph that matches that, and now we'll go write the interval notation. So starting at -1, we're going to use a parenthesis because it's an open circle. We'll go off to 1/2, and we'll use a bracket because of the closed circle on the 1/2. So back over here, the open, sorry, the less than is matching up with the parenthesis. The less than or equal to is matching up with the bracket. So, and there is just a shorthand or a very short explanation of interval notation. I assume that you have seen it before, but I wanted to review it before we start solving the equations. So. Okay, now we're actually going to start solving some inequality statements. So the directions are going to ask us to solve, whoops. Each inequality. They may ask you to graph on a number line. We're going to say graph the solution set on a number line. And then I'm going to go ahead and have us practice the interval notation. So we'll say and write the answer using interval notation. A long set of directions. It took us longer to write the directions than it is to actually going to do the work. Okay, so let's go ahead and solve our first example. So example 1, let's do x plus 1 is less than 5. So when you're solving a linear inequality, you're going to use the same general steps that you do when you solve linear equations. So you want to make sure that you remove any fractions. So step 1 would be to clear fractions. We will do an example involving fractions here in a bit. You're going to multiply every term by the LCD, the lowest common denominator. I don't have that problem here. The next thing to do would be to get rid of any parentheses. So distribute to remove parentheses. The next step would be to collect the like terms on each side. And then finally, in step 4 is where we could pick up our example. You want to make sure you move all the variables to one side and all the constants to the other side. So move variables to the same side. And constants to the other side. So we didn't have to clear any fractions. We didn't have to do any distribution because we had no parentheses. Everything is in terms of moving things already collected. So we're going to move the minus the 1 to the other side by subtracting it. That'll give us x is less than 4. And we're done. We do need a step 5 down here. I see that I'm running out of room again, so I'll try to write it kind of smaller. 5, the last step is usually to divide both sides. So if we had a coefficient, we would have to divide that out. The one thing you want to make sure you remember is don't forget to flip the inequality. If you divide by negative. That's one of those quirks. That's why they usually put these in a section by themselves, is because of that. Let's move that up a little bit or angle that down a little bit. So don't forget to flip the inequality if you're dividing by a negative. And we'll do one of those so you'll see what I mean by that step. Okay, so we're done solving. So this is the actual answer in terms of an inequality. In terms of the number line graph, we know that we have 4 because it's a less than. We'll use an open circle, and numbers that are smaller than 4 are to the left. So then the interval notation that matches up with this would be negative infinity with a parenthesis to 4. And because of the open circle, we'll use a parenthesis. So all of this is basically what we're looking for as an answer. So these will be some of the shortest problems you work tonight that we'll see all semester, in fact. Okay, let's go do a couple more. We've got some steps. I'm going to kind of leave the steps there one more time. And show you how to follow them, and then we'll erase the steps and have more board space. So let's do a set with parentheses in it. Oh no, let's do fractions. So let's do, this is example 2. Let's say we have x over 3 is greater than or equal to 2 plus x over 6. Okay, so the first thing we're going to do is we're going to clear those fractions. We're going to multiply everything by the common denominator. The common denominator between 3 and 6 is 6. So what I like to do is write the 6 by each of our terms. And I usually write the 6 on the front side, just so we know that we're multiplying. And why are we doing that? Well, 3 goes into that 6 twice, and 2 times x would be 2x. For the next term, 6 times 2 is going to give me 12. And for the last term, the 6's are going to cancel completely, and I'll just have an x. So when I'm done with that first step, I no longer have any fractions at all. Okay, we don't have any parentheses. I have nothing to collect. In other words, there's nothing to collect on this side or this side. So we're going to come in and start moving things. Always move the smaller variable. It just makes life easier for you. So I'm going to move the minus x. That'll give me x is greater than or equal to 12, and I'm done. There's no coefficient to divide by. In terms of a number line, this is saying that for solutions, we have our 12. Because it's a greater than or equal to, we'll use a closed. And all numbers that are bigger than 12 are to the right. So there's what the number line graph looks like. The interval notation then would start with a bracket because of the closed circle and the equal to on the inequality, going off towards positive infinity with the parenthesis. And there's example 2. My dog is barking outside. I don't know if you can hear that or not, but I do apologize. Example 3, let's throw in some parentheses. We have 8 minus 4 times the quantity 2 minus x, and that's going to be greater than negative 2x. So we have no fractions this time, but we do have a set of parentheses, so we'll distribute, and don't forget that you're distributing a negative 4. So that would be 8 minus 4 times 2 is a negative 8. The negative 4 times the negative x is going to make that a positive 4x is greater than negative 2x. And that got rid of the parentheses for us. Now we'll collect like terms on each side. So what that's saying is that the 8 minus 8 is canceling out. I get 4x is greater than negative 2x. Before you panic about it, don't worry, it's going to work. We'll go ahead and move the smaller variable, which in this case is the 2x. It's the smaller one. We'll add it to both sides. That's going to give me 6x is greater than 0. And then we'll go ahead and divide everything by 6. Because we're dividing by a positive 6, we don't need to worry about the inequality. We'll get x is greater than 0. So there's our solution. On a number line, what we're saying is here is 0. We need an open circle because the inequality does not contain an equal to. It says not to include the 0. We need numbers bigger than 0, which are to the right. So the interval notation that would accompany that would be a parenthesis, 0 to infinity, parenthesis. And there it is. And that's your solution. Let's look at an example where we have to deal with that pesky problem about dividing by a negative. So what if we have, this would be example 4. Or minus 2x is greater than or equal to. No, let's do a less than or equal to. Less than or equal to negative 6. Okay, so no fractions, no parentheses, nothing to collect on each side. So what we're going to do is go ahead and just move the constants to one side. So we're going to subtract this 4 to put it to the other side. So that gives me negative 2x is less than or equal to negative 10. At this point, we're going to come in and isolate the x by dividing everything by a negative 2. Because we're dividing by a negative, we need to remember to invert or flip the inequality. Negative 2 divided by negative 10 is a positive 5. So our inequality went from less than or equal to a greater than or equal to. So x is greater than or equal to 5. If you did not do that, you would get a solution set that's incorrect. So we'll show you how to check it here in just a second. So let's take it to our number line. Here again is the 5. The greater than or equal to says closed circle. And we need everything to the right. So we're going to go off to the right. So in an interval notation, we're going to start with a 5. We'll put a bracket because of the equal to and the closed circle. It heads off to infinity again with a parenthesis. So let's actually come in and check an answer. Because you're solving, you can check. That's true. Anytime you solve, you can check, which is really nice in algebra because you know whether or not you got the right answers. So let's come in, and what we're going to do is we're going to pick a number that is bigger than 5 and check it. So let's let x equal, oh, I don't know, 7, because that's bigger than 5. So back in the original, it says 4 minus 2, and in place of the x, I'm going to plug in my 7. And is that less than or equal to negative 6? Well, that's 4 minus 14, less than or equal to negative 6. 4 minus 14 is a negative 10, and sure enough, that is to the left of negative 6. So it definitely works. Sorry, ran too low down on the board. So we can see that 10 is, yes, less than or equal to negative 6. So it works. You can check it. If we had not flipped that inequality, we would have picked up numbers that were to the left. We would have gone in this direction. And if we checked one of those numbers, like x equal 0, let's do 0 because it's the easiest one to pick. And again, this is an incorrect. I just want to show you that it did not work. If we plugged in 0, we would have had 4 minus 2 times 0, which is 0. So 4 is not less than negative 6. It doesn't work. So that's why you flip those inequalities. just one of those quirks. Okay, so we did an example of a fraction. We did one with parentheses. We did one with where we had to divide by a negative. Let's go ahead and do one that involves a compound inequality. So that means more than one inequality statement. So this is example 5. Let's do 4 is less than or equal to 2x plus 2, which is less than or equal to 10. So 4 is less than or equal to 2x plus 2, which is less than or equal to 10. So for the first time we see an inequality in 2 different spots, it's okay. Instead of having just a left side and a right side, we have a left side, a middle side, and a right side. So whatever we do, we have to do to all 3 spots. So the first thing we're going to do is go ahead and subtract out the 2, because what we want to do is get the x that's in the middle all by itself. So instead of just isolating from one side, we're isolating from every side. Subtracting the 2 is going to give us 2 is less than or equal to 2x is less than or equal to 8. This point, to get the 2 in the middle by itself, we're going to divide by 2. And again, whatever you do on one side, you have to do to all the sides. So we'll divide everything by 2. It's a positive 2, so there's no impact on those inequalities. That's going to give me 1 is less than or equal to x is less than or equal to 4. And there's our solution. But now we have to go graph it. Here's my 1. Here's my 4. In this case, they're both going to be closed circles because the equal to's. And what this is saying is x is bigger than 1, which would be in this direction. It's also telling me that x is smaller than 4, which would be in this direction. So x is trapped between 1 and 4, and we'll see on the graph that our answer is trapped between 1 and 4. And now we can come in and write our interval notation, because the closed circle will start with a bracket. We're going to start at 1. We're going to go off towards 4 with another bracket. And there's our answer. And there's your first compound inequality. Let's do one more of those that involves some fractions, just to get a little bit more practice at fractions. If you're going to struggle, that's where you're going to struggle, is with those fractions. So, example 6, we have 0 is less than 1 minus 1/3 x, which is less than or equal to 1. So 0 is less than 1 minus 1/3 x is less than or equal to 1. Okay, so my order of steps said to clear those fractions first. In this case, I'm actually going to go ahead and move the 1 and then worry about clearing the fractions. It's a little bit less work. So -1 is less than a -1/3 x, which is less than or equal to 0. At this point, to clear the fraction, let's just multiply everything by 3. And in this case, I'm going to multiply everything by a -3. Because I'm multiplying by a negative on the inequalities, I need to remember to flip them. So please note that you're going to flip the inequality when you divide, which is the first example I showed you of this, or also multiply by a negative number. Okay, so in this case, we're going to multiply everything by -3. So we're going to multiply this by a -3. We're going to multiply this by a -3. Now we're going to multiply this by a -3. So -3 times -1 gives me a +3. I'm going to flip the inequality to a greater than. The -3 times the -1/3, the 3's are going to cancel. The negative times the negative gives me just a positive x in the middle. And on the other side, again, flipping the inequality to a greater than or equal to, 0 times anything is still 0. And you'll notice that we have a true statement here, that 3 is bigger than 0. If I hadn't flipped those inequalities, it would say that 3 is smaller than 0, which is a false statement. You've got to remember to flip those inequalities. So on a number line, that would give me 0 and 3. Make sure they're in numerical order. Okay, on the 3, because the inequality, we know we need an open circle. On the 0, because of the inequality, we know we need a closed circle. You'll notice that x is smaller than 3. That's what this is saying. X is smaller than 3, so that would be in this direction. X is bigger than 0, which is in this direction. So my graph is trapped between the 0 and the 3. In terms of interval notation, we're going to start off with the 0, with the bracket, that's the closed circle, and the equal to. We're going to head off towards 3. We're going to close that off with a parenthesis, and that's the open circle and the inequality statement. there's another example of a compound inequality. Okay, example 7 is our last example for the day. Again, these are all linear inequalities, and they're linear because we haven't seen any exponents floating around. We haven't seen any x squareds for quadratics or x cubes like we ended up factoring yesterday. So, example 7 says the quantity x plus 2 times the quantity x minus 3, and we want that to be less than the quantity x minus 1 times the quantity x plus 1. Well, that definitely does not look like the previous examples, but because we see parentheses, we'll go ahead and FOIL to get rid of those parentheses. From the first one on the left side, we'll get an x squared for the first term, that's x times x. The outside term is going to be a minus 3x. The inside term would be a plus 2x, and the last term would be a minus 6. I'll go ahead and do the same thing on the other side. So we now have less than. On this side, we'll get an x squared. We'll get a positive x from the outside foiling, minus x from the inside foiling, and a minus 1 on the last term. You'll notice that these are called the difference of squares, where we know that the 2 x's in the middle will cancel out. So we'll collect like terms in the next step. So that's x squared minus x minus 6 is less than x squared minus 1. And next, you want to try and get everything on one side. Right now, it looks like it's a quadratic, but the minute I try and move those x squared terms, they're going to cancel out. So what's left is a negative x minus 6 is less than a negative 1. We'll go ahead and move the 6 to the other side to isolate the x. So we get negative x is less than, what, 5? And then we're going to divide out that negative 1. And that's going to give us x is greater than a negative 5. Boy, I ended up with a lot of greater thans in this example. So because of the inequality, we know we need an open circle. We're going off to the right because we need numbers that are bigger than that. So our final answer in interval notation is going to be negative 5 to infinity, parentheses on both ends. We're excluding or not including the negative 5 as part of our solution set. Okay, as a comment, you can also use set builder notation, just in case the online homework asks you to use that. Set builder notation. What you have there is a bracket that's set. You're going to say x such that x is greater than negative 5. So this bar right here means such that. So this is the set of all x's such that x is greater than a negative 5. Sometimes you can also just use it as x is greater than negative 5. Just depends on the book's author and what they like to do. Sorry. I tend to use interval notation because we'll use it when we move forward into chapter 3. So it comes in handy to master that interval notation now so you can use it further. And that wraps up section 1.5. That's the beginning of the homework that is due on Saturday. So thank you and have a great day.